Hello and welcome to another video. In this week's video, we are dividing larger numbers and we're using the partial quotient strategy. So let's go ahead and take a look at our first problem. 642 divided by 6. When we're using the partial quotient strategy, our first step is to set up our division problem. So 7 into 642. And unlike the standard algorithm, we're going to go ahead and draw a line right here on the right. And this side will be all of our partial quotients that we will add at the end. And right here will be all of our partial dividends. So the first thing I want to do is I want to think. 642 is a large number, right? So I don't want to have all of my options be single digit numbers. I want to go up into the multiples, the tens or hundred multiples. So I'm going to write down my divisor and use the so 7 times 1 is 7. 7 times 2 is 14. Okay, 7 times 5 equals 35. And from here, we're just going to use the multiples of 10. So we can do 7 times 10, that is 70. 7 times 20, that is 140. 7 times 50, that is 350. And I can go up one more, and I can continue this pattern until I feel satisfied. So I went up to 7 times 100 and I got 700. Now 700 is bigger than 642, so I will not be using this fact. So I'm just going to use my easy fact, 7 times 1 through 7 times 50. Now these numbers right here, these are going to be the numbers that I'm subtracting or the numbers that I'm thinking of. So the first thing I want to do is I want to say which numbers over here, which one of these answers will get me close to 642 without going over. If I look at all my facts and my answers, I see that 350 is the biggest and I will not go over 642. So I'm going to go ahead and take away 350 from 642. Then you want to think, how did you get this 350? Well, we got it from this fact, 7 times 50. So I'm going to put the 50 on the outside. So 7 times 50 equals 350. So now I'm going to take away. So 2 take away 0 is 2. 5 take away 4, I can't do that, so I need to go borrow 1. 14 take away 8 is 9. And 5 take away 3 is 2. I'm going to repeat this strategy. Which of my answers is closest to 292 without going over? Well, 350 is too big, so my next biggest answer is 140. So I'm going to go ahead and take away 140. Think about how did you get this 140? 7 times what gave me 140? I don't need to think about that fact again because I already did. So 7 times 20. So I'm going to have 20 on the side. 7 times 20 equals 140. Now take away 140 from 292. 2 minus 0 is 2. 9 minus 4 is 5. 2 minus 1 is 1. Again, think about which number goes closest to 152 without going over. And again, that is 140. So I'm going to take away 140. How did I get this 140? I did 7 times 20. So when I do my subtraction, I have 12 left over. So now I need to think, which one of these answers can go into 12 without going over? And if I look at my facts, I see that 7 is the only number that can go into 12 without going over. So I'm going to take away 7. How did I get the 7? 7 times 1. So 12 minus 7, that leaves 5. So there's no numbers here that is smaller than 5, so this will be my remainder. Now let's go to the side and we're going to add up all of these partial quotients to find my final quotient. So 50 plus 20 is 70. 70 plus 20 is 90. 90 plus 1 is 91. So my answer is 91, and you want to make sure that your numbers line up with in your place value. 91 remainder 5. So this is my final answer. Okay, let's go ahead and do another. So this time my divisor is 3, so I will need my factors for 3. So let's go ahead and set up your problem. 3 into 288. Draw a line on the side for all of our quotients. And now I'm going to do my facts for 3. 3 times 1, 3 times 2, 3 times 5. And now I'm just going to do the multiples of these numbers. 3 times 10, 3 times 20, 3 times 50. I already know that 3 times 100 will be too big because 3 times 100 will give me 300. That's too big. So let's go ahead and find the answers for these first three. 3 times 1 is 3. 3 times 2 is 6. 3 times 5 is 15. Now, because I'm multiplying by multiples of 10, I know that all I have to do is just annex or add on a 0 to my original answer. So 3 times 10 is 30. 3 times 20 is 60. And 3 times 50 is 150. Now I'm going to go ahead and subtract to find my partial quotient. So think, which one of my answers is smaller than 288, but close? So yes, I can take away 3, but that will not be an efficient answer or an efficient strategy because I would have to take away 3 a long time. So I want to find the biggest number that can go into 288 without going over, and that would be 150. So I'm going to subtract 150. How did I get that? I did 3 times 50. Now take away 8 minus 0 is 8. 8 minus 5 is 3. 1 minus 1 is 2. Again, think about which one of these answers can go into 138 without going over. 60 is my next best because 150 is too big. So minus 60. And you just want to remember to keep all your place values lined up. So how did I get 60? 3 times 20. So let's put 20 on the side and subtract. Okay, so now I have 78. Which number is close to 78 without going over? And again, that's 60. And I already know that 20 times 3 gives me 60. Now subtract. Think about which number is closest to 18 without going over, and I see that it's 15. So I'm going to take away 15. How did I get 15? I did 3 times 5. So 5 goes on the side. 3 times 5 equals 15. 18 minus 15 leaves 3. Which number is closest to 3 without going over? That would be 3. So I'm going to take away 3. That leaves a remainder of 0. And how did I get 3? 3 times 1. So now I'm going to add up my quotient. 50 plus 20 is 70. 20 plus 5 is 25 plus 1. So 5 plus 1 is 6, and 7 plus 2 is 9. So that gives me an answer of 96, and I have no remainder. So my final answer for this problem is 96. Let's try a problem with a more difficult dividend and divisor. So again, you want to set up your problem, 48 into 26,304. You want to draw your line, oops, for all of your partial quotients. Let me clean that up a little bit. Okay. Okay, so now I need to find the factors for 48, or the multiples rather. 48 times 1, 48 times 2, 48 times 5. And for this, because I see that it's 26,000, I'm going to need some really big numbers. So I am going to skip times. Actually, let's not skip. Let's continue. Until you've mastered this, you want to just stick with the all the factors that you need, even though they might be small. Times 50, 48 times 100, 48 times, I'm going to go 1,000. We should go 48 times 500 too, but we'll do that after. So 48 times 1 is 48. 48 times 2, 2 times 8 is 16. Carry the 1. 2 times 4 is 8, plus 1 is 9. 48 times 5, 5 times 8 is 40. 5 times 4 is 20, plus 4 is 24. And now I just need to annex the zeros for all of my original answer since I'm multiplying by multiples of 10. And then 48 times 100, that's times 1. So I'm going to go 48 and then add on 2 zeros. 48 times 1,000 is 48. Add on 3 zeros. Okay, so now I can look at my problem and I can tell that 48 times 1,000 is going to be a little too big because I'm getting 48,000 when my dividend is 26,000. So I'm going to change that last one and make it times 500 and see if that will be more useful. Times 500, let's see. So we'll take our answer for times 50, which is 2,400. And because we're multiplying it times 500, which is one additional zero, we're going to annex that zero. That gives me 24,000. And that is way more useful. So again, we're going to think about which one of these numbers is close to 26,304 without going over. And if I look, I see that 24,000 is closest without going over. So I'm going to subtract that. And how did I get this 24,000? 48 times 500. So I'm going to put 500 on the side and go ahead and subtract. So that's 403. So 2,304 is left. So I need to see how much I can pull out of 2,304. So 2,400 is close, but it goes over, so that is not useful. So my next useful number is 960. So I'm going to go ahead and subtract 960. And again, how did I get that? I multiplied 48 times 20. So I'm going to subtract my dividend. So that's 4. Borrow 1 from the 3. And borrow 1 from this 2. And that leaves me with 1,344. A number that's closest to 1,344 without going over, again, that would be 960. So I'm just going to take that away. We multiplied 48 times 20, so we put that on the side. 4 minus 0 is 4. Borrow 1 from the 2, so 14 minus 6 is 8. And 12 minus 9 is 3. So now I have 384. 480 is too big. So my next closest would be 240. So let's go ahead and minus 240. And to get this 240, I had to do 48 times 5. So let's subtract 4 minus 0 is 4. 8 minus 4 is 4. 3 minus 2 is 1. So now I have 144. And I'm going to continue my math over here because I'm running out of room. So we have 144. I'm going to continue. So a number closest to 144 without going over would be 96. So I'm going to take away 96. And I had 48 times 2 gave me 96. So let's subtract. Borrow 1 from the 4, that leaves 3. That's now 14. So 14 minus 6 is 8. 3 minus 9, I can't do that. 13 minus 9 is 4. So I'm left with 48. A number closest to 48 without going over would be 48, and that is perfect because that leaves me with no remainder. And how did I get this 48? 48 times 1. So now I'm going to add up all of my partial quotients. These are the numbers that I'm adding to get my final quotient. Okay, so let's add them here. 500 plus 20 plus 20 plus 5 plus 2 plus 1. You want to make sure that when you're adding, you're keeping all your place values aligned. So zeros plus 5 is 5, 5 plus 2 is 7, 7 plus 1 is 8. 0 plus 2 is 2, 2 plus 2 is 4, and 5 plus nothing is 5. So my answer is 548. And again, you want to make sure that you are putting your answers in the correct place. So 548 is my final answer for this problem. All right, I hope this helps you to understand how to solve partial quotient, and I will see you in the next one.